Very good morning, students. Welcome to the lecture series on operating systems. In this session, we are going to discuss about multi-level queue scheduling and multi-level feedback queue scheduling algorithms. Coming to the multi-level queue and multi-level feedback queue scheduling algorithms, these are applicable only if multiple number of ready queues are there. Okay, if processes are getting entered into the multiple number of the ready queues, then according to their priorities, the execution of process have been changed. Okay, so based on the number of the ready queues, we are going to describe the scheduling, then it is referred as multi-level queue scheduling, and even if we are considering the feedback from the process to the execution, then it is referred as a multi-level feedback queue scheduling algorithms. Okay, students, we are going to discuss about the multi-level feedback queue scheduling in these sessions. Firstly, what is a multi-level queue scheduling? If the ready queue has been divided into multiple number of subsections, then it is referred as multi-level queue scheduling. In the case of the multi-level queue scheduling, the process have been carried into two different kinds. One is foreground process and other one is background process. For foreground process, there will be separate queue, and for background process, there is a separate queue. Okay, if any of the process which has entered into a queue, then it will keep on continues in the same queue until it completes its execution. Means once a process has entered into a queue, there is no possibility to change its queue until it completes the execution. Okay, and thereafter, foreground processes are executed based on round robin scheduling algorithm, and background processes are executed based on first come first serve scheduling algorithm. In the case of the multi-level queue scheduling algorithms, there is a fixed priority to every process. Means during the process of execution, it is not possible to change the priority of a process. So once a process has entered into a specific queue, it keep on continues the execution in the same queue itself. And thereafter, we are going to allocate the round robin scheduling algorithm for the foreground process, because foreground processes are referred as high priority jobs. So high priority jobs are not expected to wait for long amount of the time. So we are supposed to allocate the CPU based on the round robin. Means the response time will be very small in the case of the round robin algorithm. Based on that, all high priority jobs are going to be allocated with the CPU immediately based on the responses. And thereafter, background processes are referred as low priority jobs. So we are going to follow first come first serve principle in the case of background process. Okay guys, as I earlier said, the process have been categorized into 5 different models. One is system process, interactive editing process, batch process, and student process. These 3 processes means system process, interactive process, and interactive editing process. All these 3 processes are referred under the category of foreground process. Okay, the other 2 processes means batch process and student process. These are referred under the category of background process. Okay, what is the algorithm to be followed for the foreground process? That is round robin scheduling algorithm. What to be followed for the background process? First come first serve scheduling algorithm. Which of the processes are high prioritized jobs? Here, system process is high prioritized, further interactive editing. Batch process and student process are the low priority jobs. So CPU is going to be allocated for the system process at first. If the system process queue is empty, then interactive process are going to be executed, and then interactive process queue is empty, then only CPU is going to be allocated for the interactive editing process. If no other process of system process, interactive process, and interactive editing process are there, then only the CPU is going to be allocated for batch process. And then finally we are going to allocate the student process. So if the student process is going to get the CPU only if all of its above queues are empty, then there is a problem. Hope everybody knows about this problem, that is starvation. Why starvation problem will come? Because a student process will get the CPU only if all other four kinds of process queues are empty. Means if no system process are there, interactive process are there, interactive editing process are there, batch process are there. If no all these four processes are there, then only student process is going to get the CPU. But if some other process are executing, then automatically student process is supposed to wait. This is going to lead to infinite waiting of the student process. That leads to the starvation. To avoid this kind of the problem, we are going to propose a solution. What it is, the CPU cycles are going to be categorized. 80% of the CPU cycles are going to be allocated for foreground process and 20% of the CPU cycles are going to be allocated for background process. So, 80% of the CPU cycles are going to be allocated for the foreground process and 20% of the CPU cycles are going to be allocated for the background process. Based on this, we are going to avoid the problem of the starvation. Now let us have the discussion about multi-level feedback queue scheduling algorithm. In the case of the multi-level feedback queue scheduling algorithm, there is a possibility to move a process from one queue to another queue. This is referred as a feedback. So if any of the process has entered as a low priority job and further it has improved its priority, then we can enter this process into some other queue to execute it. That kind of possibility is there in the case of the multi-level feedback queue scheduling. But this is a problem in the case of the multi-level queue scheduling. In the multi-level feedback queue scheduling, we are going to assign the CPU by considering some of the parameters. Those are number of queues. If the number of queues are minimum, then automatically the problem is going to persist like the earlier. Okay. Thereafter, what kind of scheduling algorithms are to be followed? In earlier, we have followed round robin scheduling algorithm for high priority jobs and first come first serve scheduling algorithm for the low priority jobs. Likewise, what kind of scheduling algorithms are supposed to be followed? And thereafter, how to improve the priority of a process. Likewise, how to demote the priority of a process. These are going to serve as the parameters in the case of the multi-level feedback queue scheduling algorithm. Here we have been given with a small example about the multi-level feedback queue scheduling algorithm. Here there are three different queues: Q0, Q1, Q2. Okay. Firstly, every process will enter into the Q0 queue. So every process is going to enter into this particular queue. What kind of algorithm is going to be followed here? Round robin scheduling algorithm is going to be followed here. How much of time size is being given? 8 milliseconds of time was given. So firstly, whatever the process it is, P0, P1, P2, P3, likewise, any of the process it is going to be assigned with the CPU for 8 milliseconds. Then it is going to address the problem of starvation. So within the 8 milliseconds of the time, either the process may complete the execution. If it has completed the execution, it will move out of the queue. Otherwise, it will be kept into the second queue, that is Q1. Okay, even in the Q1 also, we are going to follow the round robin scheduling algorithm only. In the case of the Q1 queue, we are going to allocate the CPU for 16 seconds. Okay, we are going to assign the CPU for 16 seconds. So within the given 16 seconds of the time, the process may continue the execution. Otherwise, it will move to the other queue, that is Q2 queue. Okay, in the Q2 queue, we are going to follow first come first serve scheduling algorithm. So firstly, whoever the process has entered into the third queue, then that process is going to complete the execution at first. Okay, so students, we are having a simple example on this. For example, P2 is a process which needs the CPU for 15 seconds of time. Where it is getting completed? Q0, Q1, Q2. What is the Q? What is the CPU burst time of the process P2? It is 15 seconds. Means 5 plus is it more than 8 seconds? Yes, 15 is more than 8. Means it is not getting completed in a Q0 to Q. Okay. Thereafter, where it is getting entered? It is getting entered into Q1. How much of time is being left with this? Then it is being left with the 7 seconds. Is 7 is higher than the 16 seconds? No. Means the process is getting completed in the Q1 queue itself. Okay. Because the time interval, what is the time interval? 15 seconds. Is it lower than the 8 plus 16? Yes. That is 24 seconds. The CPU burst time requirement of the process P2 is 15 seconds and which is lower than the 24 seconds. Therefore, the execution of the process P2 will be completed in the Q1 queue itself. Likewise, you can have another example. If a process is having the CPU burst time as 30 seconds, where it will get complete? Is it get complete in Q naught? No, because 30 seconds is more than 8 seconds. Means that it is not get completed in Q naught Q. Where it is getting completed now? Where it is getting completed now? It is getting completed in Q1. Here in Q1, we are going to assign the CPU for 16 more seconds. Means 8 plus 16, that is 24 seconds. Is 30 is less than 24? No. Means it is not getting completed even in Q1 also. Where it is getting completed now? It is going to be completed in Q2 only. Okay, students? Hope you are very much clear about the feedback queue scheduling algorithm. As earlier said, first of all, any of the process has been entered into the Q naught queue. In the Q naught queue, we are going to allocate the CPU for 8 seconds of time. Within the 8 seconds of the time, either the process may complete the execution, otherwise it will be moved to the second queue called Q1. In the Q1 scheduling, in the Q1 queue also, we are following the round robin scheduling algorithm, and we are going to allocate the CPU for 16 milliseconds of the time. Within the 16 milliseconds of the time, if the process has completed the execution, okay, otherwise it will be moved to Q3. In the Q3, named Q2, we are assigning a CPU on the basis of first come first serve scheduling. Surely the process will complete the execution in the process in the Q2 itself. Thank you, students. Thank you for listening to the lecture. Hope you are getting clear about the multi-level queue scheduling algorithm and the multi-level feedback queue scheduling algorithm. In the multi-level queue scheduling algorithm, there is a possibility of the starvation, and the problem of the starvation has been addressed by dividing the number of CPU cycles into two types. Like 80% of the CPU cycles were given to foreground process and 20% of the CPU cycles were given to background process. And the problem of avoiding a process conversion from one queue to another queue has been addressed through another scheduling algorithm called multi-level feedback queue scheduling algorithm. In the case of the multi-level feedback queue scheduling algorithm, number of queues, scheduling algorithms, and improving the priority and improving the priority, these are all the different kinds of the parameters which are going to affect the process utilization. Thank you, students.